So in the next part of the video, I'll be going over a bit more complex example. It follows most of the steps as the one I covered in the first part of this video, is that there are a few additions that I will explain in a second. So we start off like we did in the last example. You let epsilon be greater than 0. You do the same process of f of x minus L smaller than epsilon. And you start reducing, trying to get this f of x minus L to look like x minus a is smaller than some expression. But as you'll see when I solve this example right up here, there's also this other term that you'll get. With that other term, you have to let delta be smaller than or equal to 1. And this 1 is just an arbitrary number that you can pick. It can be anything less than 1, just any sufficiently small number. Again, this will all make sense when I go over the example. You use x minus a to get the other term, and you substitute in a constant, and you use delta as the minimum of 1 and the expression you obtained from x minus a. I'll put all of these instructions up on the side of the video as I go over the example, so it's a bit more easier to follow along, because I know it's sort of confusing just looking at these instructions without ever having seen an example. So, okay, first step, we let epsilon be greater than 0. Okay, we start off with f of x minus L as we did in the previous example. So epsilon, we can see here that f of x is x squared plus 3, L is 4, x squared plus 3 minus 4 is x squared minus 1. And we let that be smaller than epsilon. Now we have to reduce this term, like we did in the previous question, reduce this term to look like x minus a. And a is 1. So we have to make x squared minus 1 look like x minus 1. In this situation, what we can do is we can see that x squared minus 1 is, if you factor that out, that's the same as x plus 1 and x minus 1. So we do that. Smaller than epsilon. Using our absolute value rules, we can separate these two terms. So we get x plus 1, x minus 1. Smaller than epsilon. So this was the other term that I was talking about. We have the x minus 1, the x minus a that we needed. The x minus a term is there, but we also have an extra term with x plus 1, and we cannot simply just divide both sides by x plus 1 and be done with it. We need to define some sort of constant to x plus 1. So here we move on to the next step in the list of instructions that you should see, and we let delta be smaller than or equal to 1. And like I said before, this is just an arbitrary number, a sufficiently small number that we need to look at. You can pick any number lower than 1, but it's just easier to go with 1 because it just simplifies your calculations by a significant amount. So we let delta be smaller than or equal to a 1. Now, we have to use x minus a. We know from the definition of the precise definition of a limit that x minus a is smaller than delta. Easy. But now we've also said that delta is smaller than or equal to 1. So x minus a is smaller than delta from the definition of the limit, and now we've said that delta is smaller than or equal to 1. It's easy to see that x minus a therefore is also can be written as x minus a is smaller than 1. Now, because of the rule you guys have studied in class, using the values of absolute values, we can this can be written as -1 smaller than x minus a smaller than 1. Simple. And we also know that x minus a is 1, so we just replace that with a 1. Now, our objective now is to bring this term x minus 1, which is x minus a, to look like the other term. And this was the other term that I was talking about before. This is the extra term that we really want to just get rid of in some way. And this is the term we want to keep. So bring x minus 1 to look like x plus 1. So in order to do that, for this inequality, we can add 2 to all parts of the inequality. So now we get -1 plus 2 is 1. Smaller than x minus 1 plus 2 is x plus 1. And now 1 plus 2 is 3. So now we have this inequality. And because of the same rule that we used up here to get rid of the absolute value, we can see that x plus 1 is smaller than 3. So the absolute value x plus 1 is smaller than 3. Now, I'm going to quickly erase some of this working below so we can continue on from where we actually are concerned with the question. So we've said here that x plus 1 is smaller than 3. And I'll write that up here. Okay, so now for this term, since x plus 1 is smaller than 3, we can write this same expression and substitute the 3 for the x plus 1. So we can write 3 x minus 1 is smaller than epsilon. And this inequality will still hold because x plus 1 is smaller than 3. We just substituted here, and all of that is still smaller than epsilon. So it's just a simple substitution of whatever you found through the working process. Now, since we only have the thing we're looking for, like in the previous question, we can divide both sides by the absolute value of 3, which is just 3 minus 1 smaller than epsilon over 3. And this is a lot like the previous question, it's just that we have to follow a sort of different process to get rid of this extra x plus 1 term. Okay, so as in the first example, our last step would be to put delta equals epsilon over 3, and we'd be done. But in this question, there is a bit of a problem. We say that delta equals epsilon over 3, but earlier in the question, we also said that delta is smaller than or equal to 1. We put two inequalities and equalities right next to each other. And now, since we want to reduce delta to as small as possible, we let delta be the minimum of 1 and epsilon over 3. So, over here we said that delta is epsilon over 3. Makes sense? And before that, we said that delta is smaller than or equal to 1. Whichever of the two values we want the smallest value we can possibly get. So, let's say that epsilon is 1. Then we would have delta is 1 over 3, which also means that delta is smaller than or equal to 1. In that situation, if epsilon is 1, we can pick the minimum of 1 and 1 over 3, which is 1 over 3. Just picking the smaller of these two values. But now, let's say epsilon is 30. Then 30 over 3 means that delta is actually 10, which is a pretty big value. We want to go for the smallest value we can possibly get. So now we would have delta equals the minimum of 1, comma, 30 over 3, if we pick epsilon equals 30, which would be 10. And the minimum of 1 and 10 is 1. So your delta would be 1. And either way, you found a corresponding delta to your epsilon. It's just that you did this in the weird way. And that's the sort of process you have to follow to evaluate these limits. I'm not going to do a proof for this because it's just basically substituting these values back into the x minus a smaller than delta equation to get back to the f of x minus l like I did in the first part of this video. So this was the process you should follow typically on assignments and exams and such to ensure that you get the maximum amount of points. The first example I did was a bit simpler. This one's a bit more complicated. If you still have some lingering questions or want to get some more clarifications on this content, please do leave it down in the comment section below, which I will be monitoring. I generally respond very fast between, let's say, 5 seconds to about 1 hour. So if you do have any questions, do leave them below.